Okay, so just to utilize a diagram that's not as special, what we're going to do is we're going to take this concept of sine x and x. Some might say that 2 theta takes us back to the same position on the unit circle, even though we have traveled a further distance. The reason I've stated that concept is purely to make it clear that it's not just there's not just this way of viewing it in terms of a function on an x and y graph. You can also view it as movement around a unit circle. So say, for example, at this point, let's say we produce a value of, let's try and produce this here. So this would be 30 degrees. Let's assume this is about 30 degrees round. So the hypotenuse is about twice as large as the opposite. And you can see that there are other, I do not want to have an arrow there. There are other times in which you can get that same ratio of opposite to hypotenuse. For example, at that point in the circle, you can see that therefore I can get that same triangle fitted in here. But that's not per se what I'm talking about. It's not the repetition generally that we're talking about here, because we have to have the same angle for both cosine and sine, which limits us. What I'm suggesting is whatever position you decide is what is necessary. So for us, it was just an angle of 0. Whatever position we decide that is necessary, let's say, for example, we want this angle for our sine, you can travel round comfortably the circle a 2 pi distance. That one there is too far. 2 pi distance around the circle until you get to this point again. And that is another way of viewing this concept as to why we need to consider. And notice we can do this multiple times again, infinitely many times, but this is why we need to consider again this concept of 2 pi. And because I can do this infinitely number of times, I need to say that it's 2 pi multiplied by k, where k is a constant that allows us to make that multiplication. These will be integers of infinitely in either direction, minus or positive integer values, to obtain from this diagram here the multiple outputs of 1 for cos that will all produce this length 1 that we wanted for our z cubed equals 1, and for our multiple outputs of 0 for sine, because we do not want any height. We're on the x-axis, there's a 0 height, and sine is giving you multiples of the imaginary value, notwithstanding that it is a replacement of y. If I zoom in slightly, it's a replacement of y. There is no y, and so for z cubed equals 1, as it is stated here, we do not need any value of sine. So we have to make sure, therefore, we have 1 is equal to cos 0 plus 2k pi plus I sine 0 plus 2k pi. And this now includes the extra information that will always produce that vector-esque structure in the Argand diagram that represents z cubed equals 1. Okay, now going forward, given that we've suggested that x plus iy is equal to, well, we can say that x plus iy is cubed, so really it should be that x plus iy cubed equals 1. But given that, we can therefore take this notion and say, right, we have calculated, or we have discussed, that cos 0 plus I sine 0 will give you 1, just like we wanted, because z cubed is equal to 1. We've taken into account the concept of the fact that there can be multiple outcomes that produce that same value of 1. And now we're left with this formula here for our, I do not want an arrow, this arrow seems to be following me around, for z cubed, and therefore that is where we're at today. That is to say that we have our z cubed is equal to cos 2k pi plus I 2k pi.